Hi guys, welcome back. In our previous video, we discussed about working principle of a DC motor and how it works and the construction of a DC motor. As we came to know the difference between the DC motor and DC generator and how a DC machine works, then we are going to deep dive into the DC machines classifications now. On what basis the classification of DC machines are done and what are the operations and what are the working principles of that DC machines. And all those stuff we will discuss in this video. And we have different types of classifications in these emissions. And I have given even circuit diagrams for every classification. Just go through these things. You will be fine then. First of all, we will discuss some basics on what basis we are going to classify these emissions. The, these emissions can be classified according to the electrical connections of the armature winding, and the field winding. Just this only this single statement will define the whole classification and what we are going to discuss in our whole video. Just this statement itself can define all the things what we are going to discuss. Just keep in mind, these emissions can be classified according to the electrical connection of the armature winding and field winding. This is the major point. Just keep in mind. The different ways in which these windings are connected leads to machine operating with different characteristics. The field winding can be either self-excited or separately excited. That is, its terminal of the winding can be connected across the input voltage terminals or fed from a separate voltage source, as in the previous section. As in the previous section, we discussed the voltage sources separately we have given to it. Further, in self-excited motors, the field winding can be connected either in parallel or in series with the armature winding. These different types of connections give us rise to different types of machines as well, as we will study in this section. In the sense, depend upon the type of voltage we are directly applying to how the voltage is being applied to the terminal, we are broadly classifying these emissions. In in one of the process of application of voltage uh, between the terminals, we have further divided like how it's going to excite by its own excitation, or we have to use some other external device to excite the machine. This is the brief classification of an DC emissions. Now, first we will discuss about what we call uh, input terminal or feed from an input terminal voltage terminal DC emissions. Input terminal something. I think you're able to get what I'm going to write. Right? I'm going to deep dive into further classification of this type of DC emissions. One is separately excited DC emission, and another one is self-excited emissions. In separately excited emission, the armature and field winding are electrical separated. Just see, this is the armature winding, this is the armature winding, this is the armature winding circuit, and it is a field winding circuit. These are both are separated, right? Electrical separate from each other. The field winding is excited by separate DC source. This these field welding will be excited by using an external DC source, which in turn will make out this rotation of this motor. This is known as separate excited machines. The voltage and power equation of the machine are same as those derived in the previous section. Note that input power is VFIF plus VPIA because here we are applying some power and here we are applying some more other power. The whole power can be the sum of VF IF VF plus IF plus VT IA VT VT IA. This is the whole power given to this circuit for the rotation of this shaft. This is the main point. And self-excited machines. In this machine, instead of separate voltage source, the field winding is connected across the main voltage terminal. Yeah, this is the main voltage terminal, right? We are going to connect across the main voltage terminal itself. Field welding, we are going to connect. See, so we are connecting our field welding across the main terminal itself. So we don't need any separate circuit for excitation of field winding separately. Yeah. One is shuttle mission. The armature and field windings are connected in parallel. The armature voltage and field voltage are the same. Here VT equal to VF. That's what it is. The total current drawn from the supply is equal to IF plus IA. The total input power is equal to VT into IL, because IL is the total power being drawn from this main voltage source, right? The total power is VT into IL. Voltage, current, and power equations are given. I didn't mention those equations over here because those things look uh, filmy, like those are a bit messy things. So I didn't mention those things here. Yeah. Two series DC machines. We discussed about parallel DC machines over there. Now we are going to discuss about series DC machines over here. The field winding and armature winding are connected in parallel. See, in the previous video, we have this field winding and armature winding are connected in parallel. I mean, sorry, in parallel. Field winding and this armature winding, field winding and armature winding are connected in parallel, right? But here in next classification, we are going to connect this field winding and armature winding in series. So these are known as DC series DC machines. The field winding and armature winding are connected in series. The field winding carries the same current as in the armature winding. A series motor, wound motor is also called universal motor. This universal in the sense that it will run equally well using either an AC or DC voltage. These these are the series DC machines are widely used in nowadays because these type of configuration can work on both DC supply and AC supply. It is a major advantage of this configuration. That's what I know here. Reversing the polarity of both the stator and rotor cancel out. Thus, the motor will always rotate the same direction regardless of the voltage polarity. See, why it's working on both AC and DC voltages. Reversing the polarity of both the stator and rotor cancel out. If you are going to change these polarities and we are going to change its rotor polarities also, the chain between among both of them will cancel out. So it going to rotate in the same direction itself. That's the major advantage of this type of DC machines. And we have another type of DC machine is known as compound DC machine. If both DC and shunt windings are used, like if both series and shunt fielding in one configuration itself, both we are going to use both series and shunt fielding are used. The motor is said to be a compound. In a compound machine, the series field winding is connected to the series with armature, and the shunt field winding is connected in parallel. Two type of arrangements are possible in compound motors. So, yeah, in compound DC machine system, we have two types of compounding. One is cumulative compounding, and another one is differential compounding. If the magnetic flux produces both series and shunt field winding are in same direction, in the sense, both are adding up. The machine is called cumulative compound. In differential compounding, if two fluxes are opposite direction, the machine is known as differential. Because of what we call, if both fluxes are in different directions, there is an opposition between the fluxes itself, which will cancel out some of the energy, which is intent useful in rotating the motor. So it is known as differential compounding. In both the type, Connection can be either made shunt type or long type. Short type, short shunt or long shunt. These are one of the major points. Just mark this. This is the brief classification of these emissions. I hope you guys got an basic idea about classifications of these emissions. And we will in this video we will discuss about torque and EMF equations of a motor. I mean DC emissions and power equations and power factor, all those stuff. Okay, guys, this is all for this video. Meet you in the next video. Bye.